Well, now we are going to talk about explainable artificial intelligence in the context of how to apply it in continuous delivery and in relation to what we name or what we say the intelligent organization. So we are going to talk about what is an intelligent organization. We are going to say that we are not there yet. So we have some pieces to get to the intelligent organization, such as MLOps, CD4ML, domain-driven design, and so on. And we are going to explain how all these pieces fix together towards this kind of intelligent organization. The missing piece, in my opinion, is explainable artificial intelligence. So we are going to talk about what is explainable artificial intelligence, of course, what is it, and why we need it. My proposal is CD4XML. This is a variant of CD4ML that is continuous delivery for machine learning, but using explainable machine learning models. So the first, what is an intelligent organization? Maybe you are familiar with this image, no? If you are in the analytics file, maybe you have seen this picture many times, and it talks about the types of analytics. We can talk about three types or three steps in the analytics evolution. No? The first one was descriptive analytics. Descriptive analytics is classic analytics. Use your data to make dashboards, reporting, and so on, in order to knowing what is happening in the company, no? Or what has happened in the past. Now, in my opinion, we are in the second stage. Predictive is related to predictive models, machine learning models. You know, machine learning models use the data to find patterns in the data and use these patterns to predict. So some say, well, predictive analytics is about what will happen, no? In the company or with your customers, or predict what your customers are going to do, and so on. Well, many companies are in this second stage. Many companies are using big data technology. Many companies are working on machine learning and so on. But I think we are not yet in the third stage, that is prescriptive analytics. No? Prescriptive analytics is about prescriptions. It's about artificial intelligence telling us what to do. It's about going from data-driven decisions that we are here in the second stage in predictive analytics to a third stage that is about collaboration between humans and artificial intelligence or machine learning models in the company. No? So we are not there yet. In my opinion, we are in this path that goes from predictive analytics, where we are right now, to prescriptive analytics. And for me, the intelligent organization is here in the third stage. We need to arrive to this stage to have intelligent organizations where the decisions are taken between humans and artificial intelligence in an agile way. Agility here is the key. No? So we are not there yet, so where are we? Where are we today? Well, we have machine learning operations. Machine learning operations, or MLOps, is continuous deployment of machine learning models. It is DevOps applied to the file of machine learning. Maybe you know the term of DevOps, I suppose, no? Many of you. is development operations, so development and operations. And in this case, when we talk about MLOps, is applied to machine learning models. We need continuous deployment for this life cycle of machine learning models to automate the stage of design machine learning models, develop machine learning models, put them in production, and then operate the models and monitor them. No? We need continuous integration and continuous deployment pipelines in order to do this in an automatic way. No? The focus here in MLOps is on culture, roles, and tools that we need to get this, no? This life cycle. Continuous delivery for machine learning, or CD4ML. This is a term that we use a lot in Thoughtworks. It's similar in some aspects to MLOps. It's about principles of continuous integration and deployment, continuous integration and deployment, but applied to machine learning. The idea here is we have data, machine learning models, and code in 3 parallel tracks, and we focus on different stages of the life cycle of the 3 tracks, from the first one, model building, to the next one, model evaluation, to put this model into production, to test this model, then to deploy this model in production, and then monitoring and observing the model. No? We want continuous integration and continuous deployment to cover all this life cycle of machine learning models. You can say, well, this is the same, no? MLOps is very similar, but here the focus is on improving the value provided to the users. They are very similar, but the focus is not in culture, tools, roles, but also more in how to improve the value that we provide to the users. No? The focus is more in continuous integration, continuous deployment, and this philosophy. But MLOps and also CD4ML have limitations in this context we are talking about. Why? Because they don't provide support to connect these machine learning models with business. In both MLOps and CD4ML, we are talking always about this life cycle, no, of machine learning models. But these models are separated, disconnected from business. So business goals have to be translated into machine learning models in a manual way. Each company make this connection the best they can, but there is not right now maybe a way, a framework to have continuous delivery and continuous integration, including the business issues. No? The business is out of this life cycle. So this breaks this continuity and this agility that we are looking for in continuous integration, in continuous deployment, no? Because we cannot apply these techniques to the whole life cycle, including business. So if you know domain-driven design, do you know the term, DDD, or domain-driven design? We use a lot in Thoughtworks. Well, DDD, or domain-driven design, is intended to connect business with development and deployment of software artifacts. In fact, data mesh, do you know data mesh? It's a new concept. In Thoughtworks, of course, but the rest of the public, I don't know. Well, data mesh is a new framework, we can say that applies DDD principles to the world of data. In data mesh, we talk about data as a product. No? We talk about data products that are domain-oriented. So in data mesh, we work with domains, and in some way, we define data products that are aligned or oriented with these domains. No? So we can ask, could we apply DDD also to machine learning models? If we change this data product for a machine learning model, maybe we can apply very similar principles. Maybe. So let's consider DDD as one piece, no, in the puzzle we are looking for. Well, if the question is if we can apply DDD to the world of machine learning, for me, the answer is yes. Yes, but only if we can connect machine learning models with domains. No? Here the challenge is, here we can connect data products with domains because we are getting input data from operational systems or whatever using the domain language. But here, how can we connect this model with the domain? No? Especially when the machine learning model is a black box model. No? Well, so the answer for me is yes, we can use DDD for machine learning, but only if we can connect domains with machine learning models. And I think to this end, we need explainable artificial intelligence. So this is the reason why we are here today talking about explainable artificial intelligence. So what is explainable artificial intelligence, or XAI? XAI is about methods that allow explain the decisions that are taken by machine learning models. Because we can say many machine learning models, the output of them is decisions, no? Classification or decisions. Here is very useful to talk about white boxes and black boxes, no? Because some machine learning models are white boxes and others are black boxes. White boxes are explainable by themselves, no problem here. But when we have black boxes, algorithms, we have a problem with the explainability of them. So white boxes are, for instance, linear regression or classification trees. If there are data scientists in the public, you know these terms, no? Linear regression, classification trees. Classification tree, for instance, is a clear example of explainable artificial intelligence and white box models. No? Here in the right side of the slide, we can see an example of a classification tree. Imagine a bank that is trying to have a machine learning model to decide if they borrow money to a person or not. Using a classification tree like this one, it's very easy to explain why you are going or you are borrowing money or denying simply looking at the tree. No? If your age is less than 25, let's go to the branch on the left. We are going to have your job, your income, and if your income is below certain quantity, we deny the loan. It's very easy, no? It's very clear. If the bank needs to explain a decision, it's very easy. You only have to open the white box and say, look, no? It's very easy. But deep learning, well, deep learning models are black boxes. The problem, deep learning is the situation, is that deep learning is probably the dominant approach nowadays in artificial intelligence. It's the trend, everybody wants to do deep learning. Deep learning sometimes equals to machine learning or artificial intelligence in the mind of many people. But deep learning is about black boxes. No? If you look at the picture in the right side of the slide, well, this is the aspect a neural network has, no? You know, deep learning is based on neural networks where we have an input layer, an output layer, and between we have many layers, many hidden layers. Here we see only two, it's easy, but real models have hundreds or maybe thousands of layers. No? So when you open this black box, you see thousands of this layer with maybe millions of connections between the neurons and so on. It's very difficult to understand for a human what is happening here. No? So this is a black box. This is the reason I think we need to put more focus on white box machine learning models, no? On explainable artificial intelligence models. We need to go beyond the deep learning models to find solutions for explainability. Well, there are a lot of methods, no? In explainable artificial intelligence. It's a file that is very hot. There are a lot of research. We have many methods, approaches, and sometimes it's difficult to find your way, no? In this. I think it's useful to have a taxonomy of methods for interpretability. No? We can look different aspects to classify an interpretability method. For instance, we can classify them according to local versus global. No? If we try to explain only a single prediction or predictions one by one, we are talking about local approach. If we try to explain the overall model as a whole, we have a global approach. Well, the second point, the second criteria is model-specific versus model agnostic. No? Here we can see, no? Model-specific is when we apply then these methods to to a single model or a type of models, for instance, to deep learning. And other methods are model agnostic. No? They can be applied to any model. The third criteria can be data types. Some XAI methods can be applied only to tabular data, and other can be applied to text or maybe to image or maybe to graphs or whatever. No? For me, maybe the most interesting criteria is the last one, no? The purpose of interpretability, what we are looking for. We can try to have white box models from the start and say, well, we don't work with black box models. We are going to work only with white box model, and this way we have interpretability from the start, no problem. This is an intrinsic approach. No? The second one is post hoc. Is when we say, well, I have black boxes, I have a lot of deep learning models in my company, so I don't want to change this, but I'm going to try to explain later. The deep learning models make decisions, and I'm going to put something around or after that is going to explain the decisions, post hoc. Another one is when we try to enhance something in particular, no? For instance, fairness. For instance, we try to remove the bias of a model, for instance. And the fourth one is text sensitivity of predictions. This is a very interesting approach because it's very related to security. There are many words that see how changing something in the input of the model, we can impact the output very much. So this is very important for security. And well, it's another approach in XA methods. So It's impossible here to explain or to talk about all the methods, but we are going to talk about some of them. Before we talk about the specific methods, and we talk about deep learning, no? These methods you see here, are specific. They are only for deep learning. Most of them can be classified in these two categories, saliency maps and gradients. If you look here, you can see 4 images, and we are applying different algorithms to them. These algorithms can be classified in saliency or gradients. Saliency maps are topographical representations of the inputs that are more relevant. You see here, what are the more relevant input or pixels in the image in order to make decisions or to classify the image. And gradients is a variant that tries to quantify how much a change in its input dimension, to what extent a change in its input dimension is going to change the prediction. They are based on the same idea. Another approach, very interesting, is to create white box models. No? These methods are based on linear regression. I don't know if the term is familiar for you. Well, linear regression is about the relation in a linear way between an input and an output. No? For instance, if you have here, I don't know, the meters of a house, and you have in the vertical line the price of a house, probably you can find a linear relation between the meters of the house and the price. No? If you have a small house, the price is whatever, and if you have a bigger house, the price is much more, according to a linear progression. Well, white box models are based mostly in this idea. And we can talk about additive models that only allows for addition, subtraction, and multiplications of input features. We can sum, for instance, input features in a linear way to have the output. Other methods are rule-based. The idea here is use linear combinations of rule-based features. It's the same idea, but here we are working with rules. The components are rules. Well, this way, if we use linear white box models, it's very easy to have domain-related features that are in the same language that use the domain, and in this way, we can connect the features in the input of the machine learning model with the domain. And domain, remember, is the layer that connects business with machine learning models in this case. No? So if we use white box models, this connection is clear. We have a way, no, to work on and to connect the inputs with the domain. And the predictions can be expressed in terms of domain-related prescriptions. So we have the connection, no? Domain features related to the input of the machine learning model and predictions that are expressed in terms of domain and influence the business, no, at last. So our proposal is CD4XML. No? Before we talk about CD4ML, here we are putting this X for explainable machine learning. And basically, it's continuous delivery for explainable machine learning models. No? If we sum the three pieces we are talking about, CD4ML, DDD, and XAI, we have CD4XML. No? Remember, CD4ML allows for continuous delivery of machine learning models. DDD allows for connecting explainable machine learning models with business goals, and XAI, the last piece, allows for these explainable machine learning models that we need. What is the relation between CD4ML and the intelligent organization we were talking about in the first slide? In continuous delivery of machine learning models, we are in this cycle, and we are applying continuous delivery and continuous integration techniques to this life cycle. That data ingestion, data processing, modeling, put these models in production, and have decisions that are translated into actions, and if the actions are executed, they change the real world, they change the business. No? So the idea here is using this approach, no? Where we are using DDD to connect business rural decision with features in ML models. Then we apply CD4ML to have continuous delivery for these models. And as we are including the business in the whole life cycle, we have this kind of continuity and agility connecting all, no? The business, the machine learning models, the artificial intelligence. And for me, this is maybe what we need to support this kind of intelligent organizations based on predictive analytics that we were talking about in the first slide. No? Well, thank you very much.